everyone, welcome to this video. In this video we are going to solve question from December 2016 consisting of 4.75 marks. The question is the functional g of y, which is given to be integration from 0 to 1 y dashed square plus x square dx, where y at 0 is given to be minus 1 and y at 1 is given to be 1 on the given straight line y is equal to 2x minus 1, has which of the following? You need to suggest whether this functional has weak or strong maxima or minima. So let us get started. Let us firstly evaluate the extrema to this given problem, the given functional. To calculate the extrema, let us use the Euler-Lagrange equation, that is f of y minus d dx of fy dash is equal to 0. So in this case this is our f. So what is f of y? It is 0 minus d dx of fy dash. So it is 2y dash is equal to 0. So we have solved this kind of equation many times. So its solution would be y is equal to ax plus b. You can check this, right? So now let us use our given conditions, boundary conditions. We are given y at 0 is equal to minus 1. So we have minus 1 is equal to b. So the value of b is minus 1. Let us use another condition, y at 1 is equal to 1. So let us substitute it here in this equation. We have 1 is equal to a, and what is the value of b? It is minus 1. So you will get a is equal to 2. So ultimately we get the extremum as y is equal to 2x minus 1, which is same as that given in this question, right? So our next task is to determine whether this functional is a minimum or maximum, and another thing whether this is a weak or strong minimum or maximum, right? So what should we do to see whether it is a minima maxima or weak or strong maxima? We have a result known as Weierstrass result, which is the sufficient condition to determine whether it is a minima or maxima. So for this we need a Weierstrass function. What is that? That is e of x y y dash p. It is f of x y y dash minus f of x y p, that is you just replace y dash with p, minus y dash minus p multiplied by derivative of f with respect to p at the point x, y and p, right? So let us first evaluate this function e in our present case. So what is f? Let us see what is f. Our f is this thing, right? Y dash square plus x square. So let us write this here, y dash square plus x square. Now you just replace y dash with p, so we'll have p square plus x square minus y dash minus p as it is, and then the derivative of this quantity with respect to p, so that would be 2p, right? So we have y dash square plus x square minus p square minus x square minus 2p y dash plus 2p square, right? So this x square and x square cancels, so we have y dash square minus here is minus p square and plus 2p square would become plus p square minus 2p y dash, which becomes the whole square of y dash minus p whole square. So now depending on the sign of this function e, we can determine whether it is a minima or maxima. If the sign of e, it is a positive function for all x, y, then it is a weak minima. If this E is less than equal to 0 for all x, y, then it is a weak maxima. Moreover, if this E is greater than equal to 0 for all x, y and y dash, where this y dash is arbitrary, then we have strong minima. And if this E is less than equal to 0 for all x, y and y dash arbitrary, any y dash, then we have strong maxima, right? So let us use these results. You can remember these conditions. So in our case, we are having this E as positive for all x, y. Being a complete square of something, it is always positive, and whatever y dash you take, so for any arbitrary y dash, it is positive, right? So you can state that this is a strong minima. So let us see our options. So option C is the correct option. It is a strong minimum. Moreover, we have one more result which states that a strong extremum is also a weak extremum. So this results follows that it is being a strong minimum, it is also a weak minimum. Being a strong minimum, it is also a weak minimum. So the correct options are A and C. I hope you like the video. Please do subscribe to our channel. Thank you.